Hi, Olof here. This is a follow-up video from a Tech Talk video about the Orbea Rise versus Specialized Turbo Levo SL, where different voltages are used to design motors with different properties. So what are the differences between a 36 volt and a 48 volt system? I got a few comments from viewers from our last video, where some claimed that the difference in thermal loss were insignificant between 36 and 48 volt systems. I responded to those comments trying to explain further, but sadly many of those comments were then removed by the viewers. So I thought I would go a little bit more into depth with this video, trying to explain the differences. First of all, I am an engineer, but I have not worked with these motor systems before or anything that has to do with electronics at all. I'm just interested to learn and share my findings and discuss them with you. I know that the real world is more complex, but I have fact-checked almost everything in this video with people that actually do know something. This is also not the video where I prefer 48 volts over 36 volts just because I think I'm onto something. I just want to learn. With that out of the way, let's get to it, shall we? The legal limit in Europe for e-bikes is 250 watts of continuous power. That is the power which the motor can run forever without overheating. At 250 watts, a 36 volt motor draws around 7 amps, which is quite a lot. Proportionally, a 48 volt motor draws around 5 amps. So a 36 volt motor draws around 33% more than a 48 volt motor. Looking at forklifts, for instance, they typically use 80 volt systems and put out 7 kilowatts at 88 amps. Electrical cars use even higher voltages. The Tesla Model 3 has got 615 kilowatts combined power and uses a 400 volt system, which draws a whopping 1535 amps at this power output. Electrical cars use that high voltage to allow for more power to be transferred with less loss. The drawbacks for higher voltages in electric cars include the need for higher voltage rated components in the entire system. The single biggest enemy of energy efficiency is thermal loss in an electrical system. The thermal loss is proportional to the square of the current following this formula. To make matters worse, heat that cannot be dissipated quickly generate an electrical resistance in wiring components, making it more difficult to maintain power output. And the motor and the battery management system will automatically and gradually reduce the power output. A motor that runs at its rated continuous power, that is 250 watts for e-bikes, does not overheat. An educated guess is that the largest thermal loss occurs in this order: the motor management system or battery management system, in the battery and in the cables. Since there aren't lots of cables in an e-bike and they're very short too, I think we could probably skip the thermal loss in the cables. That's not significant. And here's also where all the misunderstanding in the comments from our last video occurred. Some viewers thought I referred to the thermal loss in the cables, but that's just a very small part of the whole equation. So to generalize, the torque is proportional to the current in the motor, or a more correct way is to say that 50% more load at a given RPM means that 50% more current is needed. Again, to generalize, the voltage controls the angular speed of the motor. To control the speed, the voltage is chopped into smaller pieces by the motor management system, which in turn also affects the current and the torque of the motor. The upgrade that was available from Bosch in June this year changed the characteristics of the motor, but also raised the peak torque output from 70 to 85 newton-meters. It was all software related, so no changes in the hardware were needed. So how did they achieve that? The answer is quite simple really. Bosch allowed for more current to flow through the motor to generate more torque. The downside is that at peak torque, the motor, controller and the battery now also generate more heat, which in the end reduces the range. It's all down to what you prioritize. As long as you don't use peak power or peak torque output, the range should still remain about the same. Worth mentioning is that when manufacturers talk about torque, it's always peak torque they talk about. Something that can only be achieved for shorter runs before the motor starts to overheat. But e-bikes are restricted to have 250 watts of continuous power. And also worth mentioning is that if the motor speed is the same in a 36 volt system and a 48 volt system, the torque at 250 watts will still be the same in both systems. But the 48 volt system will need 33% less current to reach 250 watts, thus producing less thermal loss. In short, yes, less current means less thermal loss and better system efficiency, which in the end means better range. It also means that the windings in the motor can be made smaller with a smaller diameter, which also means that the weight is reduced in the total system, which is important for an e-bike. In a world where we buy carbon parts for hundreds of dollars to save a few grams, even for e-bikes, it's an important factor to weigh in. Another factor that I only will touch on is that a higher voltage system will not suffer as much from power drops when the battery is only half full, for instance. It's actually the voltage that drops quite a lot, affecting the power output in the end. I failed to find some numbers to quantify the difference between a 36 and a 48 volt system. It's difficult to find such number from motor manufacturers, so I really wasn't sure if there is a measurable difference here. But after having talked to someone who knows about these things, I'm now convinced that there is actually a significant and measurable differences between these types of systems. But we need to compare apples to apples here. All components needs to be designed and optimized for their specific parameters and use case. I have recently tested the Specialized Turbo Levo SL, which has got a 48 volt system. And I was surprised over how much range I could get from a 320 watt hour battery. After more than half a day in the bike park, I had over 70% left in the battery, which triggered my interest to find out more about these types of systems. But the 48 volt does not tell the whole story. The torque from the Turbo Levo SL is only around 35 Newton meters, which is significantly lower than most other motor systems. That is why it's difficult for me to say that the Turbo Levo has great range because of the 48 volt system. How much current and torque the motor management system allows is a huge factor as well. My guess is that it's the combination that results in good range. The Orbea Rise uses the Shimano EP8 motor, which is a 36 volt system and can still get a decent range from a small battery. That motor has been restricted to use 60 Newton meters at peak torque, and more important, probably less torque than a standard EP8 motor under normal use. I really struggled to find a good answer to this question. Maybe some of you know more than I do. I first thought that the 48 volt batteries were more expensive, but when comparing them, it does not differ that much. I think the answer to this question is because of history, actually. It all started out with 12 volt batteries and 12 volt motors, then it doubled to 24 volts, and lots of components around 24 volts were very common. Then 36 volt components started to be more common, and it was only a decade or two ago where we started to see new battery technology coming into the market. So I think we're stuck with the 36 volt system because of history, not necessarily because it's the best system. I don't think we will see systems with more than 50 volts, since that's a safety classification limit in many countries. There's a higher risk for shock with higher voltage. As I just said, I don't see why not. Most hub motors nowadays have 48 volts. And if there's something I missed here, please do tell otherwise. I think newer generation motors will have 48 volt standard. Please comment below if you agree or don't agree. I would like to hear your thoughts, and thanks for watching.